Hi everyone, and welcome to this session. As the name may suggest, we're going to talk about a real-life representation of our facility, of a production facility, or whatever facility you have in your company. This is the topic, and just before we get into this, I would like to introduce myself. My name is Pavel, and I represent two organizations. One of them is a non-profit organization which specializes in health and safety, and we mainly help out all kind of production companies generally all the companies in terms of how to improve health and safety at work. And the second organization that I represent is a commercial organization, and this is basically with our main area is the same, health and safety, and all to do with this. And we approach it from the side of IT, software, and also we approach it from hardware, so we're like a tech company as well. And we do all sorts of different exciting things, and one of them is actually the drones, and the way we can use them in our companies, in facilities, in production, and in helping to improve health and safety. And to get back to the topic of this session, I would like to elaborate on this real lifetime representation. So in my opinion, there is what we can see and what we can kind of represent it. How can we represent a digital twin? There are three main areas that we can divide it into. It's basically a physical space, or the whatever facility we're talking about, of our company, of our facility. The second one is the work that goes in that facility. So it could be all sorts of work processes and machinery and whatever production tech that we use in that facility, or workflow that we do there. And the third area is, I think, in my opinion, is one of the main ones, and that we kind of focus on now, is the people, and how area in terms of how, from a digital kind of perspective, we can tackle this. But I think this is the three main areas that we can split things into. And this is if we talk about companies and kind of their facilities, not going into things like cities and so on. And when we're talking about a digital twin, we usually, whatever we do, whatever solution we come up with, we split it also, in my opinion, in three main areas. One of them is probably the easiest one, is monitoring. So whatever we do, we try to capture it and just keep capturing it and looking at it in a way. The second one is analyzing it. So we get the data and somehow we process it, and we make all sorts of different analysis. And it stops there, because then there is a certain workflow, a different workflow that can go after that what is this analysis used for. And the third one is actually when we control. So when we take the data, we capture some data, we take it, we process it, and there is a workflow that allows us to get the signal back, so get the feedback, and to tell our machinery or whatever environment or workflow, let's call them actuators, that we have in the facility, and we give them commands of what we want to do. So it kind of, for me, it splits into like this matrix that we have, 3x3 matrix. And from there, it's basically whatever you see is all the solutions and the platforms and so on, and services in terms of digitalization and creating digital twins. They kind of split into, somehow they fit into one area or another, and sometimes they fit into many of these spaces, some of the spaces at the same time. And today I want to talk to you mainly about the first area, the physical space. What other facility we have, how can we create it in a digital space which would represent it as accurate as possible. And it's like having real twins. They look the same, they look very similar, but they have their own characteristics, and they have their own character. And this is kind of a similar thing for me. How do you create this digital twin which kind of looks exactly the same, but certainly has a different kind of way of working with it, because it is in a digital space. Coming back to the main topic, and there are all different kind of certain approaches to this. There are people that try to remodel their facilities in 3D space, create accurate models that they can work with, and they can map their whatever software analytical tools that they have to that model. But what we have learned, that the most accurate thing is to actually have, in a way, a 3D model, but I would call it a 3D scan, to scan the facility. And this area, this area of work, it's not very new. It's been with us for a while, and it's used a lot in the construction and other different areas. But the tools that are in they have existed for some time. But the way that we can actually work with those tools these days is really easy. I mean, well, not easy, but it became very accessible. So you as a company, or you as a representative of the company, you can start integrating these tools today, and it would be not very expensive, and it would be, it could be really, really fast, like in a day or in 2 days. So yeah, the 3D scanning, how do we actually do this? There are two main approaches, and I'm going to talk about them in a bit more detail further down, but just to outline them now is basically we have 3D scanners on one side, and we have photogrammetry on the other side. So at the 3D scanner, we go with a laser and we take measurements really, really, really fast, and a lot of them, and then we map it into 3D space. And photogrammetry is when we take a lot of photos of our facility, and then we stitch it together with some algorithms and some special software that allows us to make a 3D model out of photographs. And basically at the end, everywhere we get point clouds. So like these points in 3D space that make up of our object, our facility. And these points, they have accurate, it depends, but it varies, but let's for the sake of this argument, let's call them accurate measurements. So they can be mapped into 3D space in terms of where are you geographically, and then they will relate to each other very accurately. So they are like in real life, but they are in digital space, and they have color. and depending on the solution again, but for the sake of the argument, the color is basically represents very accurately of what that color is in real life. So those point clouds, they can consist billions of points, and they make up this 3D model. And I think we're just going to dive into this, and I'm going to show it to you because visually it will be much easier to understand. Okay, so let's have a look at this. This is the platform that we provide. This is one of our products. I'm not going to talk about its features or that's the particularities of our solution. I'm just going to use it as a tool to show you how to work with this kind of information and what it allows you to do. But you can search web, for similar software, and there are different options that you can pick from, and pick whatever is most suitable for your work. But anyway, so what we get initially, we have flown over the site with a drone, and we have these photographs. We upload it to whatever software we use, and in the processing it gives us these outputs. One of the first output is the 2D representation of the our area, and basically it's all the photographs are being stitched together, and we get one big photograph, and then it's mapped onto a the geographical points where where the facility is actually situated. And you can see here that around this it's a map, and it's a kind of image that you get from Google Maps or something like that. And you can see, this is the most of the solution that we get on this level of zoom. And then we get to this 2D representation, and one of the main things is that actually it's a lot of resolution that you get here. It's very, very detailed images. And this image is being stitched. This image is stitched together, so it's one whole thing. And already it's a simple first step, but it's already like, wow, we can have a look at our facility from the top, and we get this kind of level of detail. So it's important in terms of the work decisions that can be made already from this image. But this is only the beginning, and then we get. Let's have a look at other outputs that we get. The next one that we can have a look at is digital surface model or digital terrain model. There is a difference, but for the sake of this argument or this presentation, I'm not going to go into detail. But mainly it's about having your heights from the ground of the ground represented in 2D space or 3D space. And in this particular case, we're looking at an image of the different height levels on our side. And again, it's pretty amazing what you actually get as an output, that already you have this kind of map of what are the heights, and you get all these sorts of legends and things like that. So this could be used in the work as well. And this kind of things that we get in the 2D space. And then we go into 3D space, and basically this is what we get from all these 2D photographs. We get a 3D model. This 3D model, that's what I'm talking about. This is the real life kind of representation of your site, and I would call it a digital twin, a true digital twin. It's static, so now in our world of doing this kind of work, we have two types of digital twins. One is a static one, which doesn't change. So you take a snapshot of your facility at one point in time, and then you have different type is the dynamic type, where things can actually happen within this model. And this is more advanced stuff, but I will maybe talk about it further down, but I'll try to get through the simple stuff so you can actually, see the how this tool can be used for you. And so yeah, this is the 3D stuff. And also, well, you can get more outputs out of this. You can have all different drawings like counter lines, and you can get actual 3D mesh model, which could be used in software or whatever. So yeah, there are more outputs that you can get out of this, but today we're going to look at that, like two simple things, a 2D representation, a 3D representation. And again, we go into the detail, and we can see a lot of detail. And this is amazing because this level of detail, how can we capture outside? Let's go and take pictures, and then we look at the pictures. It'll be really hard to get something like that, and also that fast. And I think I'm gonna just mention a few words about this as well, how fast this actually can be done. So this kind of project, it takes about, half an hour, maybe 20 minutes. It depends on the resolution and the area of the site, what we're trying to do. But it's quick, and it's really quick in terms of getting started, and it's really quick in terms of getting this first model into works. It takes a bit of time once we're actually flown over it to upload the data and then to process it. Again, it depends on the software that you use, but it can get up to, it can go from about 2 hours to 10 hours or so. It depends on the project and depends on the solution. And also in really advanced stuff, when you have like cities and infrastructure of miles of area covered, then you actually get a lot of processing time. But this area that I've showed just now on this project is quite quick. Okay, so the next thing that we can have a look at is how to actually get flying, and get that first picture and the first set of pictures that we can use for creating our models. And I'm going to show you all the DJI drones because it's just much easier to show one set of drones to work from. There are mainly, I'd say 4 types that they kind of split into. You have like a beginner level, then you have like semi-professional, where you have kind of a lot more features, and then you get like this more professional stuff, which is like industrial grade and industrial type for heavy duty work. And then you have specialized drones. Basically they can go anywhere from agriculture to drones that go kind of inside tubes and stuff like that. Anyway, so just to give you this understanding of how broad of a tool this can be, I'm just going to run through a few examples, a few things that can be done with drones, and then we get back to the digital twin as well. I mean, this is part of creating a digital twin, because digital twin is not one thing, it's a lot of different tools and approaches that can be taken with this, and many of the things can be combined. So one of the first things that the drones can be used is for the inspections. So we go around our facility and we can make inspections on where everything is whole and safe. And why I think it's important and why I think it's a good kind of area. First of all, it's safe. I think one of the main strong arguments for drones is that it's safe for people. And when we go into a kind of dangerous facility, or where there is certain type of high risk work is happening, or there is a lot of machinery, or conditions that are dangerous. It can be very safe for people to just get into a safe landing position and to start your drone from there and take it around the site. And yes, it can be unsafe as well in the hands of people that don't take precautions and not qualified to do so. But it's easy to get qualified. I mean, not hard to get qualified. There are a certain type of courses and so on. But it's one of the main reasons it's very safe to take it onto the facility side. The second thing is the economy. It's economy of our time and economy of our financial resources. If we're talking about inspections, if we have in the place where there is high ground, where we have to climb and like cranes or roofs and things like that. Again, it's not only unsafe, but it can be expensive. One case where I think it's that stands out for me is in the oil industry, where they have this, I'm not sure if it's the correct name, but they have this oil torches and gas torches, or oil candles, gas candles, I'm not sure how they're called, but basically those pipes that burning the excess material in the oil and gas industry. And sometimes they have to maintain this, and the way they do it is they actually go up on that thing, and it can be dangerous, but it's also expensive, to send people there, and it takes a lot of time as well to prepare for this and to make all the available tools and so on. So with the drone, you just go up and stick your camera in there and you have a look at it. And from there you can make a decision if you need to actually take it down for maintenance or not. So the inspection in this kind of areas is very, it could be much easier with these kind of tools. Also, it kind of gives you this new dimension. So if you are going on an inspection, a visual inspection, well, first of all, you look with your eyes, and mainly you can take pictures or you can take videos, and with the drone you get this new dimension which you kind of get from the above, but also you can go all the way around, which opens in many industries and in many types of facilities, which opens kind of like this new dimension where they haven't seen it from, or they have, but not every day because the access is hard. And one of the actually ways of having inspections is inside the platform. So here in the platform I have opened a different view, different project, and also if you look at the right hand side, we have this inspector tool. Again, it could be different from different solutions, but for the sake of this presentation, this is the way I'm going to show it. So we have this facility, whatever it's. You can look at it. You can look at it from different sides and so on. And this flight has taken us 15 minutes to do. So we've gone outside, spent 15 minutes outside, waited for the drone to finish, and actually we don't need to do anything. This is the thing that I forgot to mention. The way the drones fly is you have a special app on the phone or a tablet where you just give it like a area that you want to fly around. You set it up and it sets up this grid automatically, and you just start. And so the drone flight for this project, the flight time was 15 minutes, and it took another maybe 30 to 40, maybe maximum of an hour to process all the data. So let's make it 2 hours in total. We get this, and it probably, well, it's about 300 or 400 pictures, and it probably could have taken a lot more for the person to go around with the camera and take pictures. And the other thing is that you would actually never get pictures from above. So, well, you could go climb up the roof, but that would take a lot more time and a lot more effort, and it would cost a lot more. So the way it works, we select some kind of a point in our model. I'll just click here, and then we get all these pictures that are associated with it. And then you can open this picture in the big view, and you can scale and zoom in and so on. Again, I'm not going to go into the details of the platform, but it depends on the tools that you use. You can have inspection on those photographs. And the other way you can use it is not just having to look at it, but to actually mark it somehow and make comments about it and so on. And it can be another advantage of this is that it's stored. So you have your kind of you captured this footprint of your facility at this certain date and time, and you have all these photographs associated with it. Then, depending on the tool that you use, you would go into your project, you would mark all the different things. Then you can follow up on it and create tasks and so on. And doesn't matter how you do it through your existing systems or whatever. It's basically this one storage space that you can always go into, and then go into your timeline, and then let's select 3 months ago and have a look at it. And there was this, and let's have a look at it today. This has been fixed, and so on. So I think this is a really cool tool. Another area of using the drones and the digital twins in it's monitoring the environment, and I think today it's very important, and it's one of the major kind of global concerns that we are facing. So how it can be done? First of all, let's have you have a facility in the area where you have a lot of forest. With the drone, you can have a scan of that area with taking images or a different type of payload that goes onto the drone. So you can scan the area, and then it will allow you to do a lot of different things. But for example, there are solutions where you can calculate the indexes of forestation or deforestation, and also the vegetation indexes, and DVI and so on. So this allows you to monitor and control of how much damage your facility is doing to the surrounding area, the forest or lake or whatever. Again, this can be stored, and it could be calculated, and it could be analyzed, and you can go in different, track the changes in different times of the year, of the day, of the year, and in terms of months and so on. Okay, so let's have a look at this mountain, like green space that we have here. So we can, again, we get a 2D image, which is really a lot of details. From this, you can actually, see the visual changes of the area. So we have almost 2,000 meters. It's a lot of area that can be covered with drones, and then you stitch together, and you could have a visual representation of this. But also from the images, there are other type of tools that can instruct those vegetation indexes and so on. Those digital twins that you can have, where we can have a dynamic type. One of the examples would be to set up those environmental monitors like CO2 or other type of gases that are being released from the facility, to monitor the levels, and then you can map it onto the digital twin, and you can actually see like in sorts of heat maps, like how much are we exhausting into the environment. And it's another way of having this live tool, not just being in terms of a dashboard or mapped onto a map, but to actually have it in the representation of your 3D facility, real life like facility. And also with all the indexes that you can have for vegetation, there are certain types of algorithms that different companies do. There is a project that we do as well, but mainly is we get information from a certain area of green space and the indexes of vegetation in there, and then we get data from monitoring devices of the gases, and we can have this data being, well, first of all, analyzed in terms of we project that much into atmosphere, and the vegetation index and other indexes, that's how they're changing with the time. And also with the data that you collect for like a month, 2 months, a year, 2 years, whatever, you can start building models for the future. Okay, so there are just a few things that I still want to show you, and I think they're the most kind of exciting in a way. Let's get into this. So one of the really good examples of a specialized use is drones in the mining industry. There are special drones that are made like a sphere, and they're surrounded by like this cage that protects the drone. So those drones can go inside things. They use it in oil industry when they go inside enclosed spaces or inside the pipes, but also in the mining industry when they go inside the mine. And let's have a look at this mine. So from the outside, we get this model, and basically the drone has flown inside, but we get this model as if it's a 3D object also from outside. So from the outside it looks a bit weird, but once we go inside, we start seeing that the black things that you see is basically the point clouds rendering because of the amount of points in this model. But anyway, so you see the inside walls, and we see a lot of detail in there. We see a lot of detail in terms of the structure of the mine, the material of the mine, all the things that kind of make this landscape of the mine, put it like that. And in terms of the structural analysis, this could be a great tool where you can see the whole mine and go around it and analyzing its walls, structural integrity of the mine. And with different platforms you get different tools, but most of them have things like measurements, for example, from side to side, and you can get a lot more other stuff, but that's not the point. But you have a set of tools that you can start working with this data. And mainly, like, I would say the main use case for this project would be to analyze if the mine is safe to go, and to see if there is any change in the structural integrity of the mine. And also one other thing that I think is worth mentioning, if we look here, if we go to this side of the mine, right at the beginning, you can get all these details like the mesh netting, and the piping. And this also can be not just like the natural material, but also the man-built material within the mine. It could be analyzed, of its structural integrity and so on. So yeah, I think this is one of the really good specialized cases and one of the exciting cases. And also, it's not just mining, other sectors that kind of use all different techniques and how they can tailor this kind of set of tools for their needs. But one of the industries where drones have actually been used quite a bit in terms of surveying the site is the construction industry, and I think it's one of those industries that has adapted this technology really fast and really well. So here we see a construction site within some kind of area, and when we zoom in, the map around it disappears because there is not enough resolution on the map. But so the zoom finished there for the, let's say, Google Maps. But once you go in, like for the 2D stuff, it gets really a lot more detailed. And one thing to mention here is it's actually maybe a couple more zoom stops. But the main idea here is that this was done in about 15 minutes. And I think this is an important point to mention, that in terms of the resolution of the 2D images and the 3D point cloud, one of the main things is how high we fly. So the lower our altitude is, more images we would need to get. So the more images, it's more resolution, and therefore we will have a lot more detailed the 2D image and the 3D model. So if you want to get a lot of details, you need to fly lower, but it comes at a cost of it being a bit longer. So it's always the balance, and you have to figure this out for your use case and for your goals that you're trying to achieve. The balance of finding, do I want to do it quickly and frequently, or do I want to do it not as frequent, but I need more detail. And so here with the construction side, again, we can use all kind of set of tools like measuring, and we can introduce here other things like measuring the area. Just quickly. So yeah, we get this area of this sand piles. And then you can do the same thing in the 3D space. And one of the beauties of this is that all those measurements that you do in 2D, they translate to 3D space as well. And as you can see, it's quite a lot of detail, yeah. And to compare it with the traditional methods, it's not as detailed, of course, when you go with a measuring station. But again, it's much more accessible and it's really quick. So if you want to do something really fast and you need to get an idea of what is happening right now at the construction site, I think it's really a useful tool. So here we go. This is one of the good examples as well of how this can be used. And also to go a little bit further, if we go back to the open mine that we had, one of the tools that can be used in that kind of setting is measuring the volume. So let's have a look here. For example, we have this pile of dirt or whatever that material is, and then we can, I'm gonna do a really rough kind of selection just to make this quicker. So we get this selection and we get the area and we get all the dimensions, but also, like in this example, we have this button for the volume, and straight away, like in 1 second, we calculated the volume of this pile. And for the people that do, surveying this kind of stuff in their work, like in the coal industry, I know it's a big one. It's just a really useful tool in terms of doing things fast and maybe not as exact as it would be. Again, it's one of those things that has a lot of discussions, and there is certain tests that show that this actually is as accurate as doing with traditional measuring methods. It's not the tools that we use, it's basically how much detail you put into when you've been flying. So if you've done a really good job at capturing the data, the measurements that you would get of the volume, it's really good. It's detailed. And also with this you can add things like, adding some kind of density of the material, and then you would get the mass of this volume. So yeah, this is just showing, number of tools in terms of measuring and capturing the data and working with the data. And also this could be used in I would put it into more organizational kind of things, where you can map your area with certain drawing symbols, or highlighting the areas and so on. This is useful if you want to do training or some kind of education or some kind of information for one of your providers that will go into the site. So when they go before they go, they would get an access to the platform, and you can manage the access of what they see and what they can do. But they can go in there and they can see for example, you've drawn a safe route for them, and also you've highlighted some kind of areas where there is an unloading zone and so on. And in the platform, most of them you can write annotations, descriptions, give things names and things like that. And also you could give access for your provider to do the measurements. For example, like with this mine example, this could be a good case. Like there is a road, and for example there is a provider that goes in there with a truck. So before he actually goes there and chooses the truck that he needs, he could take measurements of the width of the road and this bridge that overhangs the road. He could measure that height there, that would allow him to pick a right vehicle to go into the site. So as I said, there are a lot of use cases and a lot of methods and tools that kind of go into this, and the more you kind of get into the idea of identifying your goals and your specific needs, the tools are there. It's just a matter of finding them. And my goal today here was to kind of give you a brief introduction to this, and I hope this has been helpful. And it's now for you to kind of get inspired and to try to identify of how this can be integrated into your work. I hope you enjoyed this, and if you have any questions or things that you need to discuss, please, I'm always available. I will be trying to answer all your questions in the chats, and also you can email me as well. So thank you very much for your attention, and I wish you all good health and stay safe.